Good morning, and welcome to High Tech Jerusalem. I'm Meron, Associate Director of the Northeast Region of American Friends of the Hebrew University, and we're so glad that you can join us this morning. This event is part of our effort to bring the academic research of our esteemed faculty to you and share advances at Hebrew University, which are having a global impact. Hebrew University was founded over 100 years ago, and an important part of the founder's vision was the expansion of the boundaries of knowledge for the benefit of all humanity. Today, it is internationally recognized with 25,000 students, including those from Israel and over 100 countries. The university's significant contributions from water to medicine, agriculture to energy, brain sciences to technology are solving the most challenging issues of our day. Before we get started, please be aware that your microphone is muted. We ask that you keep yourself muted until later during the Q&A, when you will have the opportunity to ask Professor Arkin your questions. I'd like to thank our event co-sponsors, Temple Shalom of Newton, and especially Dr. Korn, whose great idea sparked this event. And also to thank the Consul General of Israel in Boston for joining us. It is now my pleasure to introduce the General Consul, Ambassador Reuben, who will make welcoming remarks. Ambassador Reuben was born in South Africa and immigrated to Israel from the UK. And he studied diplomacy and international relations at the Hebrew University in Jerusalem. Ambassador Reuben has a diplomatic career spanning 3 decades in a variety of positions, including roles at the Israeli embassies in Chile and Mexico, and as ambassador to Paraguay, Bolivia, and Colombia. Ambassador Reuben served as Israel's ambassador to the UN and as Israel's chief of state protocol. Ambassador Reuben now serves as the Consul General of Israel to New England. Ambassador, the floor is yours.
Thank you very much, Maura. Good morning, everybody, and good evening in Jerusalem. Thank you for that introduction, and thank you very much to the American Friends of the Hebrew University for inviting me today. Your work, of course, to connect Americans to the Hebrew University by raising awareness and funds for the institution and providing scholarships and fellowships is simply remarkable. And I think we all thank you for that. As a 2-time alumnus of the Hebrew University, it gives me great pleasure to be speaking with all of you during today's event with Professor Isaiah Arkin, or Ishayahu, or Ishai. The Hebrew University is known, of course, for its reputation for excellence and its leading role in the scientific community. So it comes, of course, as no surprise that Professor Arkin would speak of the Hebrew University's advancements being at the forefront. With few natural resources, of course, Israel is and has always been dependent on its human capital, and therefore education has always been of prime importance, not only to the state of Israel, but to the Jewish people as a whole. And the Hebrew University has played a pivotal role in building the nation and continues to educate successive generations of leaders and innovators. Jerusalem, of course, is now one of the leading technology hubs in Israel and in the world, and the Hebrew University is part of that evolution. I know that Hebrew University enjoys the support of the American Friends of the Hebrew University, and that support has been a central force in the university's rise to international prominence, and its friendship remains crucial to their continued success. Now, before our guest speaker, you will see a brief overview of high tech in Jerusalem.
In one of the oldest cities in the world, we are witnessing a thriving era of innovation, and the Hebrew University is at the forefront. Our game-changing work has transformed the way people drive, advanced the development of animal-free meat production, made the world a more secure place by enhancing crime-fighting technology and cybersecurity, and are creating a greener planet by developing biofuel through nanotechnology. In a country with the most startups per capita, we are leading the way. Our research has led to over 130 commercialized ventures, more than 10,000 patents registered, and over 2,800 inventions. In 100 years, we've gone pretty far, but our greatest achievements are still ahead of us. Join us in harnessing Jerusalem's innovation for the benefit of people everywhere. The Hebrew University of Jerusalem, a tradition of innovation.
Thank you, Ambassador Reuben, and thank you, Maura, and good morning. I'm Will Korn. I'm a member of the Temple Shalom Israel Engagement Task Force, and I'm pleased to have been able to work with my friends at Hebrew University to bring this program to you today. In the audience of little Zoom tiles today, I see many familiar faces from Temple Shalom and from beyond. Please accept my warm welcome. The mission of our Israel Engagement Task Force is to foster connections between our congregation and our brothers and sisters in Israel, and we have been sponsoring programs that are variously educational, cultural, and social. Today we'll focus on learning about Israeli prowess and progress in the sciences. Today's topic is incredibly timely. I would imagine that our guest speaker didn't until recently think that he could say the words spike protein and have millions of non-scientists know what he's talking about. And with the first doses of coronavirus vaccine being administered in the US only this past Monday in New York City, we will learn about the importance of basic science research that leads to such incredible life-saving technology. And it will remind us of the need to give our support to education and the sciences. Along these lines, let me introduce Professor Isaiah Arkin. Professor Arkin is the Arthur Ledgwa Professor of Structural Biochemistry at Hebrew University and the former Vice President of Research and Development at the university. Currently, he heads a team of researchers who investigate the structural biology of membrane proteins. The research has shed new light on the inner workings of the flu virus, and in particular, how the virus avoids antiviral therapy. Professor Arkin studied at the Faculty of Agriculture at Hebrew U and at the Faculty of Life Sciences at Tel Aviv University. He received his doctorate in cell biology from Yale University and is the recipient of the Alone Fellowship, the Klatschke Prize for the Advancement of the Frontiers of Science, and an award for excellence in teaching. Professor Arkin, thank you for joining us and welcome.
Let me just share my screen for a second. Wonderful. Please nod if you can see my screen. Fantastic. Okay, so it's wonderful to be here or there. I actually don't know where I am, I guess on the ether lines of the internet. Thank you, Dr. Korn, for that wonderful introduction, and to Ambassador Reuben for introducing the Hebrew University so well. And I certainly wish that I could be there in person, but hopefully within a few months, God willing, I will be able to. So what I want to talk to you about today is a bit about the impact of the Hebrew University and what we've done. And I teach unruly Israeli students. So I'm more than happy to receive any questions or anything like that. Feel free. This is what we do here in Israel. We are not afraid of good questions, only bad answers. So let me start by telling you what it's all based on. It's all based on world-renowned research excellence, the sort of excellence that you don't necessarily tout your own horn, but rather you receive accreditation by the Nobel Prize Committee, people from the Fields Medal that award the top honors in mathematics, or the Abel Prize as well, the Balzan Prize, the Turing Awards, that signifies that what you have in your faculty are literally the world's best. And it's that esteemed level of science that enabled the Hebrew University and other institutes in Israel to propel our economy and to make an impact worldwide. So I always like to show the pictures behind the awards, etc. You probably recognize some, not all, but these are the leaders that the Hebrew University was proud to have amongst its faculty, amongst its graduates, etc. We see ourselves as important in not only capturing all of the finest talent, but also fertilizing Israel's other academic institutions. But I guess what we're really famous for is the ability to translate our academic fruits, the research that we do into industry. And that's a way that we have found that makes the best impact. Now, it's not necessarily about generating revenue. It's about influence. Now, I know that you're going to hear from time to time, we sold a product that's worth so-and-so. But by doing that, you actually mean that a lot of people are interested in what it is that you do and what it is that you've produced. And that's a way, in my mind, to show in an objective manner the influence of the university. So just by way of very brief introduction, a few numbers. As you can see, we've been doing technology transfer for a really long time. In fact, we're one of the 3 oldest universities in the world that do this. Our tech transfers have been doing this for 56 years. We have a slew of patents. About a 10th of them we have licensed out. We have 170 spin-off companies. And a nice number to keep in the back of your mind is that every year there's over $2 billion worth of products that were patented by the Hebrew University. That's a nice number to keep in the back of your mind for a university that is not necessarily nestled in the standard academic hub. So let's try to put really this into perspective by providing you some examples. And more, do I have 2 hours or was it an hour and then 45 minutes? Okay, so first of all, I have something to concede. We did not come up with the COVID vaccine. The Hebrew University has done a ton of work on COVID-19, but the vaccination that some of you, I understand, have already had, it was not a direct related product from the Hebrew University. But nonetheless, what we have done is develop technology that will ensure that you will drive safely to the clinic to get the vaccine. Okay, so if you have a traffic accident on the way, the vaccine is not going to be very effective. And what I'm talking about, of course, is probably our biggest claim to fame, reduction of collisions by a mobile eye. This is a wonderful manifestation of how computer vision can be incredibly effective. And this is the most prolific inventor in Israel. This is Professor Amnon Shashua. His company is not only saving lives all over the world, but it has generated thousands upon thousands of jobs in Israel. And it's clear to say that Jerusalem is completely different from the time of before and after Amnon Shashua. And again, most of you don't even recognize the fact that this is already installed in your car. Close to 90% of all automobiles in the world use Mobileye technology to ensure that the drivers get to their destinations, perhaps the vaccination clinic, safely and soundly. Now, most people would go to retire on a wonderful island, the Caribbean. Well, not Amnon Shashua. Amnon Shashua now has another company that is aimed for an IPO in the NASDAQ. And I should mention the first company was sold to Intel for $15.6 billion. Okay, that was not a typo on my part. 15.6 billion, the largest exit in Israel's history, and the largest one by any currently serving university professor in the world. His other company, Orcam, is again a wonderful example of computer vision that is meant to assist those that are visually impaired. And in fact, newer versions will assist all of us. Using sophisticated technology and bone conduction, it will actually tell you what you read when you point at it. It will tell you the color of the lights. And most importantly, here, the color of the number of the bus, the currency, etc. This is an amazing example of the technology. And again, hundreds of employees are working in Orcam today. An example that pertains to the city of Boston is BriefCam that was bought 2 years ago by Canon. As you can see, our computer science department is very, very strong, and in particular, computer vision. This is Shmuel Peleg, and his company called BriefCam developed video synopsis. We have huge number of video surveillance cameras all around us, but who has the time or patience to sift through that information quickly? And what yes?
Presentation isn't proceeding.
Is not proceeding? Is it stuck on BriefCam or is it stuck on
Mobileye with Amnon?
Really?
Yes.
How is it now?
I still see it on Mobileye.
Okay, let me then stop sharing and perhaps try again.
Thank you.
Apologies. Okay, what do you see now?
One moment.
It says you started sharing, but it's nothing on the
Blank.
screen.
It's blank, you don't see anything?
Nothing.
Correct.
Is anyone else trying to share the screen?
I don't think so.
There's a message that says that you have started screen sharing, but other than that, the screen is black.
Okay, let me try then once again. That's odd.
It's the same thing. What if you tried sharing your desktop rather than just the window?
I'll try that.
Send it one of us and we can share.
How about now?
You should send it.
Yeah.
No, it
No.
seems to be stuck. Guys, I have Shai's presentation. If you want to make me a co-host, then I would be happy to share what I have.
Let me, 1 second, let me stop the keynote and start it again, if you will, one last time.
Okay.
That's odd, apologies.
I had a suggestion from the audience that if only you log out and back in, it may help.
Myself?
Yeah, not everybody else wait, but if you were to log out and back in again, it may help.
Okay, let's give it one last time. Can you see anything?
Nope.
Same.
Okay.
Oh,
So I shall,
yes. Okay,
you see material science?
that's right.
Okay.
Okay, so I think.
But you were able to hear my spiel?
Yes, what I think maybe go back to OrCam and explain it one more time, and then brief cam. There you go. Perfect.
Okay. Okay.
Thanks, Scott.
Thanks, Francine, for stopping me. Okay, so OrCam is another example of computer vision in which a camera which is installed on your glasses can decipher information for you. And if you're visually impaired, all you need to do is actually to point at the element that you want it to decipher, and it can read the text for you. It can tell you what the color of the traffic light is. And believe it or not, the thing that people that are visually impaired said was most important, it can tell you what currency you're currently holding in your hand. Because in the US, all the dollar signs are exactly, the dollar bills are the same size as opposed to Europe. So someone who is visually impaired is incapable of realizing if he's holding a $1 bill or a $100 bill. Okay, I'm going to the next slide. Do you see brief cam, Francine? Fantastic. Okay, brief cam actually pertains to video surveillance. We're surrounded by video cameras, and the problem with the video cameras is they're collecting these endless amounts of information, but no one really has the time or patience to sift through them to actually recognize what the important information that takes place. Shmuel Peleg's company called BriefCam is able to provide you for a real-time synopsis. Note, this is not fast forward. This is filtering out all the events and transposing them one on top of the other in real time. And in fact, this technology was used by the FBI and the CIA to uncover the bombers of the Boston City Marathon so quickly, because it actually shortens the time that it takes you to look through a video by tenfold, if not much more. And this technology, as I said, was recognized by Canon as being essential. The company was bought, and this is now used all over the world to enable us to make sense of the oodles of video data that we're surrounded with. Going to the next slide, material science. The Hebrew University has a very strong nano center that what they are trying to do is to generate new materials all the time. And one of my favorites is by Professor Metal Reches. What she's trying to do is to make a surface to be anti-fouling. And by that, I mean that any sort of harmful pathogens, and I don't think we need an introduction what a harmful pathogen is these days, harmful pathogens cannot adhere to that surface. Now, what was so brilliant about what Metal did was she actually looked at nature to see what sort of Teflon does nature make. And what we will do is we will replicate that, generate a compound as such, and actually make it stick to surfaces and then have those surfaces be completely resistant to the attachment of if it's bacteria or viruses or any sort of agent that we want to stay clear from. Another example of a brilliant young researcher, Ori Katz. What Ori is an expert in sensing in complex material. If you think about this for a second, if we look at a mirror, the light that is reflected from the mirror is perfectly clear to us. We can see what the information was. We can see our own image or anything else. And yet, if we have a white wall, it also reflects light. If it didn't, it wouldn't be white, right? But the information is completely lost due to a huge number of interferences. And what Ori is able to do is actually to make sense out of that using sophisticated mathematical manipulations, and believe it or not, can actually see a reflection through a white wall. Now you would say, okay, well, why don't you simply buy a mirror? Would that not be cheaper and more effective? Well, sometimes all of these sort of problems with sensing and imaging complex media might also be when you're trying to actually look through the human body. If you're looking at a sonogram, okay, an ultrasound, or any sort of analysis that's trying to visualize through your body, there's a huge number of reflections that need to be sifted through, and that is what Ori is doing, and for that he received huge grants from the European Union, etc. Another example of an application that in Israel we unfortunately need to rely on is the ability to detect buried landmines. Professor Shimshon Belkin was able to genetically engineer bacteria to fluoresce when they recognize explosives. Now, what he does is he sprays a suspected field with these bacteria, let the bacteria grow, and the bacteria start fluorescing in the vicinity of a landmine because tiny amounts of the explosives actually leak. What Roni Agranat, his colleague on the left, was able to do is to generate a laser scanner that sensibly makes sense of where all the laser spots recognize fluorescence. And actually the Israeli army is already using this to safely map out a landmine field and to be able to remove all the landmines. Now, of course, medicine is the most important thing that we are all concerned about today. And the Hebrew University has made some monumental contributions. And one of them that I'd like to focus on is what the late Haron Razin and Chaim, or as he's known in the US, Howard Cedar did. And that is the role of DNA methylation in epigenetics. Now, you probably recognize today that DNA is the molecule that serves as the information base for our genetic information. Now, the issue is, though, that every cell in our body contains the same DNA, the same genetic information, yet we recognize that they're read differently. After all, if they were not read differently, why would your skin be different from your muscle, will be different from your nerves, will be different from your heart, etc.? Well, what Aaron Razin and Chaim Cedar discovered many years ago was that the DNA is actually annotated by a small chemical change called methylation, and that heralded the field of epigenetics, because it's not just the sequence, it's the redacting that you do with the chemical manipulation that actually tell specific tissues, this is the bit that you need to read. Now, a younger researcher in our Faculty of Medicine, Professor Yuval Dor, was actually able to use this technology to develop very sophisticated liquid biopsy. Now, what do I mean by that? So what Yuval recognized that whenever you have any sort of pathology in your body, your cells die. And one of the consequences of cell death is that they release the genetic information. They release their DNA into the bloodstream. So if you see that your blood has a lot of DNA in it, you realize something's wrong. But the problem is, you don't know where the problem is because the sequence is all the same. But Yuval recognized that what Aaron Razin and Howard Cedar told us, that if you can figure out what the annotation of the DNA that you found in your blood, then you know where the harm is. And he was able to, with a simple prick of your finger, to actually tell you if the problem is in your pancreas, if it's in your liver, if it's in your lung, or any other place. And this is very, very exciting technology. I want to tell you a bit about Martha Weinstock-Rosin. This is Exelon, what she's holding in her hand. It is one of the highest selling drugs that came out of Israel. This is for the treatment of dementia, that one suffers from Parkinson's or Alzheimer. It's sold every year for over $1 billion, which tells you that it's not just the residents of Greater Jerusalem, or in fact the citizens of Israel, that are enjoying the benefits of this drug. It's people all over the world. And amazingly, a molecule that Martha generated more recently has now been used in Croatia, believe it or not, in clinical trials as an anti-COVID-19 drug. So Martha continues to be incredibly prolific and inventive, and it's incredibly exciting to see. Another one of our star researchers is Professor Hermona Sorek. She has studied a small molecule called acetylcholine, which is one of the signaling molecules in your brain. And she was able to uncover the differences between people that are more susceptible to PTSD than the regular population because of a molecular difference in a small mRNA, which of course is all the news today, a small messenger RNA, and she was able to uncover why it actually results in the same people in the same tank experiencing exactly the same sort of combat. 3 of them come home safe and sound, and the others are suffering from PTSD. Sorry. The last example that I want to give you from the area of medicine are one of our star researchers, Sigal Ben Yehuda, and her colleague on the left, Ilan Rosenshine. They won the largest grant that the European Union awards. These are the synergy grants, 7 million euros, to research brand new ways in which bacteria communicate with one another using these nanotubes. Not only do they communicate amongst themselves, enabling them to transfer agents that will enable them to be resistant to antibiotics, but also how they're able to extract nutrients from the host being us. And Sigal and Ilan have really pushed infectious disease research to a completely different level here at the Hebrew University. Now, I don't necessarily want to leave you with pictures of pathogens and sad things like that, rather the contribution of the Hebrew University in the fields of agriculture. And I would be remiss if I would not introduce, of course, Professor Nachum Kedar on the left, the late Nachum Kedar, and Chaim Rabinovich, may he live to be 120 on his right. And what they did is they invented the cherry tomatoes. Now, I doubt that there are many universities around the world that would be able to tell you that we have not only changed the way you drive, we've changed what you eat. And that's exactly what we've done. Okay, that's what Chaim Rabinovich and Nachum Kedar did. And the amazing thing is that before their work, there were actually small varieties of tomatoes, but they would ripen far too quickly. In fact, it was not a viable agricultural product. The ripening time was measured in hours. So that means from the time you pick them until the time you eat them is hours. And that's not a sustainable agricultural model. Nachum Kedar, on a trip to the United States, realized that there's actually strains of tomatoes that are defective and that they never ripen. So he decided, wait a minute, this is actually a good thing. All I need to do is actually to breed these into the tiny little tomatoes that ripen too quickly, and lo and behold, their work generated the cherry tomatoes that all of us around the world eat. And in my mind, if you're looking at an impact, there can be no better example. Now, my penultimate slide is what hopefully all of us will be doing come Passover, eat some gefilte fish that is made from carp. And that's precisely what our Vice Rector, Berta Levavi-Sivan, is. She is a world expert in fish endocrinology. So by that, I mean she's an expert in how to make fish reproduce one another. And I don't know if you realize that today, but the vast majority of freshwater fish that you eat comes from aquaculture. And about 50% of the saltwater fish that you eat comes from aquaculture, and that number is just going to rise. And what you need to be able to do is you need to understand precisely how you breed the fish, how you cause them to reproduce, etc. And that's what Berta and other of her colleagues are doing at the Faculty of Agriculture. So with that, I'd like to finish, but I'd like also to mention in my final slide is that we have not let COVID-19 impact whatever it is we do. In the last 12 months, since January 2020, 60 new companies have been started at the Hebrew University. And if you have a look at the different technology that you use, you can see that once again, they impact dramatically different fields. So hopefully when I come to visit you within the next few months, I'll be able to tell you more about some of these exciting technologies and more fascinating stories about research that takes place at the Hebrew University. And with that, I shall conclude, and I'm more than happy to entertain any questions from the audience.
Thank you, Professor Arkin, for such an insightful and hopeful presentation. There's a few ways you can ask your questions. One is to type it in the chat box, and I see we have a couple questions that way already. You can raise your hand through the Zoom feature, or you can literally raise your hand and we will look for you and call on you to answer your questions. I'll read the first question. Unless Rabbi Berry, you'd like to ask it yourself, you can unmute yourself.
Sure. Hi, everybody. I'm so glad that we can all be here together today. And Maura and everybody from Hebrew U, thank you so much for putting this together. Professor, it's wonderful to meet you and learn from you. So I'm curious in that, as I'm very sensitive to this personally, as a woman working in a field where women have not traditionally, been welcome. I'm curious about, there were some women scientists in the presentation, but from what I could tell, and I'm making huge assumptions here, everybody was Ashkenazic. I'm curious about what the sector looks like when it comes to diversity and minorities, and some of the challenges. And I'm curious about tech coming out of the Arab sector. I know that Israel obviously is so diverse, and I'm so curious about how all of that is unfolding. And I know there must be challenges as well. So I'm curious sort of what that on the ground looks like.
Okay, I guess I can take that. So first of all, as far as I can tell, there were 5 women and 5 men. So I had a perfect balance between men and women. And there were also Sephardic. So Amnon Shashua, the person that I led with, that is responsible for the largest exit in Israel's history, the largest IPO by a huge margin, is Sephardic. So I wish I can tell you that 50% of our faculty are, everything is split exactly 50-50, but I would say that it is changing dramatically. More than 50% of our PhD graduates are women, and the number of faculty members who are women is on the rise as well. And the same also holds obviously for Sephardic versus Ashkenazic as well. The percentage of Arab students in the Hebrew University is about 80% of what their proportion is in the country. So I would say that it's better than what one would have anticipated, but it is not equal. So we still have a ways to go, and we have lots of scholarships and special programs in preparatory years in order to prepare them for the university better.
50% is extraordinary. Actually hearing that, and this is a separate conversation. I'm so curious how Israel has worked to make that happen, because to achieve equity like that I'm sure has not been easy. So that's an amazing number.
If you don't mind another numeric, the course study program that is hardest to get into the Hebrew University, believe it or not, is, bit of suspense, veterinary school. Okay, the hardest thing to get into the Hebrew University. 70% of the students in the vet school are women. More than 50% of the students in our medical school are women as well. So I think it's just a way of showing that there's no bias. So God forbid we don't have any numerus clausus. Oh, there's too many women here, etc. So the university opens its arms, and the admission is obviously free to anyone who is capable.
I'm going to call on Jeff Cooven next. Has a question. If you want to unmute yourself.
Yes, thank you very much. I have many connections on this call. I'm a former member of Temple Shalom. We used to live in Newton. And Shai, you and I have met a few times in Israel and elsewhere. As you know, in 1973, the Cooven Center evolved as the preeminent place for science in infectious and tropical diseases, and remains an incredibly productive laboratory. Rabbi Barry, I'm really glad that you brought up the point about diversity. You know, the Cooven Center was the first of all the places in Israel, and on behalf of the Hebrew University, to develop cooperative science. In fact, they had the first cooperative project with a Middle Eastern country in Egypt well before the peace accord, and has done so throughout the Middle East and beyond. They're also the first recipient of a science grant from the Bill and Melinda Gates Foundation to do cooperative science in Ethiopia on parasitology. So there is so much cooperative science with Arab countries, with Palestinians, and it's happening right there at the Hebrew University and even within the Cooven Center. Shai, a question I have for you, and something that the Cooven Center does struggle with, is a bit of a brain drain. There are many places in the world and many places in Israel that are recruiting top-notch scientists. How can the Hebrew University focus on faculty retention, faculty recruitment, faculty development?
So first of all, it's wonderful to see you again, Jeffrey, and I hope we can get to see one another in person rather than just online. So you raise a very important point, and it pertains to what the ambassador said before. We have no natural resources but our manpower, our brain power. And if we lose that to places that are able to offer more lucrative positions, then we are in bad shape. The good news is that the Hebrew University, as well as Israel as general, is able to recruit some of the best researchers that we generate. But it's a struggle. And while we can't offer differential salaries, because those are mandated by the government, we are a public university, what our researchers are unwilling to compromise on is their ability to conduct research at the highest level. So it's quite amazing that when you have someone negotiate a new job, he's not, or she is not talking about, you know, what sort of salary do I get? What are the fringe benefits? But rather, what sort of microscope will you buy me? You know, what's my lab size, and how many positions for postdocs and students? And if you ask me, that's the sort of thing that we can't compete with. And this is what we do on a daily basis. And what we rely on is our friends and the friends organizations all over the world, first and foremost in the United States, to help us to be able to provide starting packages for our faculty members, because you can be the world's smartest biologist, but without a good microscope, you're not going to see those microbes. It just doesn't work.
Correct. And how does Hebrew University differentiate itself from other places within Israel and around Europe and the world? How can we differentiate ourselves as the place to come to for science and furthering any type of innovation?
Well, what I don't necessarily want to say is that the other places are not worthy. What I would like to say is that we are doing a very good job, and we are doing it in the most exciting city in the world. We're doing it in Jerusalem, as your dad recognized many years ago. So I think that when people talk about integration, when people talk about being a center, we've been doing that in Jerusalem for many, many years, if not thousands of years. And now we can actually utilize all of that for the benefit of mankind. So I do think that we have something innate in Jerusalem that makes us able to do all the wonderful work that hopefully I was able to showcase.
Will, you have a question?
Hi, I was hoping to pick your brain a little bit on your area of expertise in virology. So I'm going to ask a two-part question. One is, what do you think is the single most important advance that has led to the incredibly rapid development of a vaccine for coronavirus? And part two of my question is, just from the pages of the newspaper today, there's a more infectious variant of the virus in England. And I would like to know what those sort of mutations mean for the effectiveness of a vaccine that's already been developed or that will be developed in the future.
Okay, so I'll answer the second question first. Is this new viral strain in the UK, will we be able to control it with a new vaccine? The answer that we recognize today is probably yes, most likely yes, or even I'll try to be even more dogmatic. It's highly unlikely that we will not be able to. There's no reason to assume that we won't be able to. Trying to answer your first question, well, in all honesty, the West was complacent. If you look prior to December of 2019, infectious diseases as a huge family were not on the top of the list of the pharmaceutical companies around the world. And believe it or not, we had a trial run in 2002, 2003, SARS. I mean, the new virus is incredibly similar to it. And yet, because this did not knock on the doorsteps of people that live in Hamburg or London or New York or San Francisco or Tokyo, the pharmaceutical industry really didn't care. The fact that dengue runs rampant around the world, the fact that Zika, the fact that West Nile virus, etc., all of these diseases, the idea in the West was, this is something that is only worse for those in the developing world, third world. And I think if you ask me what made the difference in the speed, the answer is very, very simple. Money, lots of it. The fact that the US government paid for not just development, but production. Think about this. I mean, the Pfizer and Moderna got their FDA approval a few days ago. And there's already product that they can actually sell. So what the US government did was it actually said, start manufacturing before you have approval. If you don't have approval, don't worry about it. We will finance it nonetheless. So the very short answer is money and motivation.
We have a question from Alice and then Jeffrey.
Yes, thank you, Maura. Building on Jeffrey's comments, I was wondering, Isaiah, if Hebrew University has reciprocal agreements with other universities in the United States. I was just thinking my son works at MIT in nanotechnology, and I'm wondering if there's a sharing of research or if Hebrew University tends to keep what they've developed close to their vests or chests. I'm not sure what the expression is. So can you speak to that aspect?
Well, I would say that we have a very large number of agreements with the top universities around the world. And I can tell you as a scientist myself, the last thing that we like to do is to keep things close to our chest, because it's all about impact. If you can't influence people, if you can't let people know about the work that you've done, you're not being influential. And all of us like to work in areas in which we can say at the end of the day, look, Mom, this is what I've done. You know, it's not just I've made a car drive safer, or I've made a cure for this disease, but I've also changed the way a generation of criminologists think. I've changed the way that online sites that rank hotels operate, etc. So it's in a vast number of areas. We want to impact others. So it's exactly the opposite. We're trying to share as much as possible the results of our academic work.
So you are working with different universities in the States?
Absolutely. Absolutely.
Oh, that's good. It's good to know.
Question from Jeffrey Holzer. Forgive me mispronouncing your name.
Close enough. In Israel and many other countries around the world, water is a scarce resource. I'm curious what Israel is doing to progress on its desalination efforts.
So Israel is, and again, excuse me for throwing vanity sort of out the window, but Israel is by far the world leader in terms of water usage, okay? So if it's drip irrigation that makes watering so much more efficient, if it's water reclamation, so 80% of all the water that we use, we reuse for agriculture, 80. Country number 2 in the world is Spain, and they use 20%. So we are 4 times better than number 2 in the world, okay? So people from California come to Israel to recognize how we reclaim water, okay? Whenever you visit Israel, you always see the water pipe and drip irrigation, etc. Search for purple water lines. Purple means reclaimed water, okay? And in terms of the desalination, we're a leader in that field as well. You're probably familiar with the what we call in Hebrew the Movila Artzi. It's a very large waterway line that was bringing water from the Sea of Galilee, the Lake Kinneret, to all over Israel up until Mitzpe Ramon. Do you know that we don't pump water from the Sea of Galilee anymore? We've stopped. It's all desalination. Okay, so Israel is doing remarkably well in water management, but as every Israeli, whenever there's a good rainfall, we're always thankful. I always am amused to recognize that when I lived in the UK, the meteorologists would say, tomorrow we have bad weather, it's going to rain. In Israel, they would say, tomorrow we're going to have good weather, it's going to rain. So we appreciate rain in our part of the world.
I think we have time for one more question. If I can see if there's any more hands. I see Mark Gottesman. Do you want to unmute yourself, Mark?
Are there aspects of Israeli culture and early education that encourages so many young people to move into these areas of the science that seem very different from what I'm imagining, for example, in the United States?
Well, the very short answer is yes. Israel is a country of entrepreneurs. One might say that the entire country is an enterprise that was started 72 years ago, and hopefully a very successful one. And I think it's one of those things like a nucleation event. The best way to motivate someone to go and to be an entrepreneur, to be a scientist, is a good example. And fortunately, starting from the 70s, Israel started to generate these wonderful examples of brilliant scientists that were able to translate their work into applications, into impact. And today, the question, the wish of every Yiddish mama is not necessarily to have her daughter or son to go to be a doctor or to go to be a lawyer, but today, believe it or not, their wish is, I want you to be in the high tech. I want you to be in biotech, to agri-tech. So I think today it's already positively a working vicious cycle that we have.
Thank you.
I see Ellen Kaplan is raising her hand.
Hi, I came in a little late. I wondered if you could say how you're probably repeating how your research affects the whole COVID situation.
Okay, I didn't expand on that, but the work that has done in the Hebrew University on COVID was mostly in the area of diagnostics. So high throughput screening of huge number of people. And this was work that was done by a computer scientist, Nir Friedman. What he was able to do is use massively sequencing efforts in order to be able to do tens of thousands of tests at the same time. Not only will he tell you if you or don't you have the virus within you, but now he's able to actually to tell you which variant of the virus you have, which today is very important, especially in lieu of the news of the new strain that's coming from the UK, etc. So the university really pitched in, and close to 100 researchers, myself included, have been focusing on COVID-19 from the beginning of the year.
Thank you.
Jeff Cooven had one last thing, and then we'll close. Jeff.
So Shai, we're excited about newfound relationships with the UAE and other countries in the region and beyond. Do you forecast this as fertile ground for collaboration with the Hebrew University?
Absolutely. Absolutely. I think there were also talks, for example, with Hadassah Medical Organization, which is a sister organization to us. We share the same medical school, to try to establish a medical school in the UAE. So we are incredibly excited because science, as you know, is the true only international language. And it is wonderful to build bridges and to cement and really to fill in the normalization that we seek with our neighbors.
I see a flurry of questions. Shai, if you have another minute, I see James Shulman had his hand up, and I'm giving some chats.
As long as you'd like, no problem.
If you have 2 more minutes. James, did you want to unmute?
Yeah, I just said thank you. I was just curious, the aquaculture slide you had up, and I'm totally out of my league, but I was just curious. There's a lot of concern about the processes of farm-raised fish and whether you should even eat farm-raised fish. How is the aquaculture being used to improve that process of farm raising?
Well, I would say, like any agricultural product, the tremendous advantage it has versus going and hunting fish in the wild, which is another way of saying fishing, okay, is that you have complete control over the surroundings. You know precisely what you feed the cows, you know precisely what you feed the chicken that you grow, and in aquaculture, you have precise control over what you feed the fish. So I think if you want to mistreat this animal or any other animal, you can obviously do that. But if you want full control over what the fish have, then only aquaculture can get that. And in Israel, going back to a question that I was asked a few seconds ago, we are in severe shortage of water. So aquaculture is something that we need to do. And I think that the ability to control the surrounding, precisely what your fish are living on, will actually make fish, for those that decide to eat it, far safer and more nutritious than fishing fish in the wild.
Maura, there's a question from Howard Shulkin. Howie, can you unmute yourself?
Yes, I'm wondering the funding for the university. Is it mostly government or donations or tuition? How does the university run its operation?
So the vast majority comes from external funding. And by that, I mean normally funds like the National Institutes of Health, which we compete vigorously for, funds in the EU. Actually, the Hebrew University gets more of its competitive research funding from overseas than it does from Israel, which tells you incidentally how competitive we are. Imagine you need to convince scientists from another country that you're actually able to get those grants. We rely on our friends organization tremendously, and tuition, I don't know if you know how much tuition is in Israel. It's about $2,500 per year per student. It's a bit less than the States from what I'm told. So tuition is a very minor factor. And actually that's a wonderful thing because any student that wants to study can study. So what the university does is it continuously searches for funding from competitive sources from our friends and benefactors located all over the world.
Thank you. Yes, tuition, $2,500 would cover maybe one course.
Yeah.
Semester.
Well, I think that's the perfect place to sum up and close. Thank you, Howard, for that question. And of course, I'm grateful, of course, Shai, for your time, Ambassador Reuben for making welcoming remarks, and of course to all of our guests for joining us this morning. And yes, Howard, we rely on the support of our friends from the United States, from around the world, to help advance the important work at the Hebrew University. And so I'll take this opportunity to thank all of you who have supported us, because it means such a great deal. We can do all of these extraordinary discoveries, all of these advances that are really having a global impact because of your help. So a special thank you. It was a wonderful and inspiring conversation. And you know, as you heard, from health to climate change, food insecurity, some of the major issues, medicine, but of course, equality and diversity on campus and creating a more civil society. These are the priorities of the Hebrew University. And I invite you, those of you who are not involved, to, when we are in better times, to come visit with us in Jerusalem, to join us for future events that we're having virtually in the meantime. But of course, to feel free to reach out to me directly. You'll see my contact information on the screen at the end. If you'd like to learn more, if you have any questions, and of course, if you'd like to support this important work so that we can continue to be a light unto nations. All of us at American Friends, thank you, and sending our warmest wishes for your health and all the best for the holidays and the new year. Thank you so much.